My name is Denise de Vries and I'm an adjunct researcher at the Swinburne University of Technology in Melbourne, Australia. And I'm a chief investigator on the Play It Again to preserving Australian video games of the 1990s. In this project, we've got many games from the early 1990s that run on DOS. And when we try to run them, we keep getting messages to say that there's not enough memory to run the game. So in this presentation, I'm going to talk you through how to optimize DOS systems to use the available memory. And before that, I'll explain what the background to this whole problem is by giving you a bit of a history lesson of PC memory in the 1980s, go through the memory structure, conventional memory, extended memory, expanded memory, high memory, upper memory, then the two configuration files that we can edit to customize config sys and also accept that. And then I'll show you the utility, the mem utility, so you can see what memory you're using and analyze the effect of your statements. So in the 1980s, well, prior to this new memory structure, in the early 1980s, the original DOS had a maximum of 1 megabyte of RAM, and it was in two named sections, the base memory and the upper memory area. The base memory was for DOS and programs, and the upper memory area was for BIOS and peripherals. Now, even though there were these two named areas, they weren't managed in any way, and so programs or could actually overwrite the area of memory where another program was, or override its data and things like that. It was quite a problem. Anyway, in 1988, Microsoft came up with this new specification to actually manage the previously unmanaged regions of memory. And so this was great news. Everybody thought this is great. Unfortunately, it meant that the user had to be able to understand this memory structure and know how to configure the computer's memory to be able to run their software. So the structure of the memory was such that this was the pre this new memory handling was the 1 megabyte, which was made up of conventional base memory and then upper memory. And then you could add more memory. So we got another area that was called a high memory area and then extended memory area. And that could be as big as you wanted, as long as you wanted to buy more RAM. You could also buy an expanded memory board, and you needed another memory manager to be able to handle all that. So you had 640K here, 340K there, 64K here, and then whatever RAM you had on top of that. But because of this structure, you still had to be able to load all your programs into that base memory of 640K, the conventional memory. And if you loaded all that without using memory managers, you would get the message, not enough conventional memory. So it didn't matter what your total memory was, if there wasn't enough in conventional memory, the program couldn't run. And this is true even for emulated systems. If you emulate one of these old systems, you'll have the same problem as well, as just the same as the original hardware. So in excuse me. So in conventional memory, most DOS and many early Windows systems too, they load device drivers and the terminate stay resident or TSR programs during the boot cycle. And these programs are by default loaded into that base or conventional memory. So memory management techniques are needed so you can load the device drivers and the TSRs into upper memory area, and so then free up conventional base memory so you can run the programs. So the DOS boot sequence is such that you've got your IOSys file and your MS-DOS file, and they're both, you know, input-output systems in the main DOS system, and they're the main files in your disk operating system. Then you get the command interpreter, which is command.com, and then DOS loads config sys file, and that's followed by the autoexec back file. So the config sys file is an editable file, and a text file, and it contains all the DOS commands that you need to set up your system and inform the operating system how you want it set up. Excuse me. So the config sys commands let you specify the memory device drivers and programs that control the hardware devices or enable or disable system features or set limits on system resources. Config sys loads up at the start before the autoexec back file, and it is editable. It's text file, it's editable in a text editing program, not a word processing program, a text editor. The order that you put these commands in config sys is important, especially if you're doing the device or the device high thing to move it into high memory, because some of the device drivers enable devices that are needed by other things. So it's a hierarchical kind of setup. So the very first device driver you want to load is the HighMem.sys extended memory driver. So that's loaded first, so everything else can then use high memory, followed by the extended memory driver, and then load DOS into high memory, and then you can load any other device drivers after that. So for example, here's an example config sys. So we load first the high memory sys into memory. Then we load the memory manager, and this extension says we're not going to use expanded memory, we're not going to use the memory card, which allows for an extra 64K memory in high memory. And then we load DOS into high memory using the upper memory blocks. And then here we're loading a CD-ROM driver into high memory in the region 2 within high memory. And we'll call the CD-ROM drive D, and this is the CD-ROM device name. And this has got to match later in autoexec back. It's got to be the same name. And then we set the number of files that can be opened up at any time. This is the maximum number of files. So I've set this at 30. It's not forgetting that DOS uses 4 itself. So when you say you've got 30 files available, it's actually only 26 for your programs. Buffers are for input-output data transfer. So there's 20 buffers available, and you can set your last drive, and that's set here to the drive letter J. Every drive takes up a slight amount of memory, and so if you weren't going to use 10 drives, you could say drive E, say it's only 5 drives or something like that, it would save a little bit of memory as well. So auto exec back then gets run. And this also executes each command in the exact order in which they're being placed. And you use these commands to specify where the device programs are loaded and other DOS environmental settings. Excuse me.
Denise, that's 2 minutes.
Okay, I'm almost finished. Thank you. So a typical auto-exec bat commands, we've got LH for load high into region 2 of memory. This is a path name for the CD-ROM driver program file, and then we use the same definition of what we're calling a CD-ROM. Here we're also loading high into our region 2 of memory. The mouse driver, it's in this path, and that's the name of the mouse program. Then we're setting our sound to have the sound files that the drivers will be found in this path. And then we've set the sound card, and these are the settings for a Sound Blaster 16 card. We're setting the way MIDI music will be executed, then setting the prompts, so you can make the prompt look like anything you want to. Here it's setting the path followed by the greater than sign, and here we're setting some default paths, so that these are the search paths if the actual path isn't specifically put into the command when you're trying to start a program. And in the early days, there was no standard for temporary files, so programs could either look for a TMP or a TMP folder to put temporary files. And so we're setting both of them to the same folder. Along with these commands, there's also the mem command that displays your free memory in your system, and you can use the classify command switch to say which programs are loaded, where they are in memory, how big they are in memory, how much memory you've got free, and what your largest program size would be for you to be able to run it. And so after putting in all these commands, you can run mem to make sure you've configured your system to the best way you can. So what have we learned today? Legacy DOS systems had a structured memory with primarily 4 sections that are all a little bit different. All programs are loaded by default into the base conventional memory of 640K. Memory management commands and configs and auto-exec bat enable customized memory use, and you can see what you've done and how much memory you've got by using the mem command to report on what was used and how much free memory you have in the computer system. Thank you very much.
Thanks, Denise, for that presentation. We do have 1 minute for questions if anyone has a question for Denise. Denise, we really appreciate you staying up late at night to give this presentation. Thank you.
I can't believe I've started coughing now.
Never mind. Okay, any questions for Denise, please feel free to enter them in the chat and I'll read them out. Could you just tell us briefly about the overall project? It's about games preservation specifically for Australian games producers.
Yeah, it's specifically Australian games, and we're looking at the just the period of the 90s at the moment. We did have a previous project where we're looking at 80s Australasian games. So we looked at Australian New Zealand games, and now we're just looking at the Australian games. So there's quite a huge progress in the systems and the sophistication of the games. So it's there are quite a few challenges there with the complexity of the objects, you know, going from quite simple games of the early years to sort of networked video and, you know, movie quality and interactive and all that in the later 90s.
Great.
It's
Well,
really interesting.
Yeah, thank you so much for sharing your work with us, and as I say, for staying up late to join us. Okay, thank you, Denise. That was great.